Hey guys, it's Ben from Myers Woodshop.
It's Brian from Fiery Squirrel Art.
And today we're going to check out side-by-side comparison of the new Aeon Mira 9 with our old black and yellow, the OMTech 60 watt. It is, I'll just say this up front, it is a not quite fair comparison as in terms of power, because the Mira 9 has a, well, it's 100 watt, but it's really 90 watt tube in it. And the black and yellow OMTech, that has a 60 watt, but it's really a 50 watt tube in it. So we're not focused so much on the power in this video. We're going to focus more on just the features that each one has, the speed at which things can cut. It is a little skewed because this is more powerful. I just don't have an exact comparison to do that with. We're going to take an in-depth look at each machine. We're going to run some identical files, obviously at different speeds and powers, but we're going to try to max out what we can do so we can get a good comparison at is one worth more than the other. Up front, Aeon provided this Mira 9 for doing some videos showing it off. I did buy the OMTech with Brian. We went in halvesies on Amazon.
We paid for that one.
To get the black and yellow. The Mira 9 cost about $12,000 with tax and shipping and such. The OMTech, that cost us $2,500 or so. And then there was extra things we needed to add on. Yeah. So this is significantly more expensive, but we expect it to perform significantly better.
Much better.
It should.
Yeah.
So we've had the Orion for about a year now or so, and the Mira 9 maybe a few weeks to a month.
Yeah.
So that's our experience with the two machines.
So obviously there's a big difference here between machines. I mean, they're both Chinese built originally, but this one's had the guts ripped out and redone. This is basically stock. We tampered a little bit with it, put in a couple of meters to help us read the power a little better. Basically, we're going to look for advantages in size and speed on this one. The working bed on the Mira is significantly larger than the OMTech, and as we've seen just a little bit so far, precision and speed are probably going to be significantly better on the Mira as well.
Speaking of the both coming from China,
yeah.
To clarify this, because it was a little confusing to me at first, Aeon is a Chinese brand, but there is a company that's called Aeon US.
There you go.
So it's the same thing. You really don't know that they're two different things. Aeon US has the exclusive distributorship for the Aeon lasers in the United States. I might be wrong, but I'm 99%
we're pretty sure that's the case.
That case.
Yeah.
So what Aeon US does is they get in the Aeon laser from China. They rip out all the Chinese wiring because typically that's not up to US code.
Yeah.
They use smaller gauge wires and such, and they re-put in all good, thick, properly gauged electronics.
They ramp the heck out
inside of the machine. OMTech literally, I think, crates it in and then crates it right back out, and it never leaves the crate.
Yeah.
This thing goes through like 127 checkpoint to make sure that this thing is running and operating perfectly before it becomes available to you in the United States.
And that's kind of why the price difference is so significant. There's been a lot of time and attention put into the Mira.
Absolutely. Also, this comes with a ton of training and good videos. I mean, the videos they sent to me to get up and running were really well done. There was excellent documentation.
A lot of support.
A lot of support with this machine.
Yeah.
OMTech has no support. I think they're starting to get a U.S. presence.
Good.
And do a little bit more support,
Good.
But it's basically non-existent at this point for what I've seen.
I mean, when we bought this thing, we really didn't know if it was a shot in the dark or what, because there was little to nothing out there on how to run it, what to do if it broke, any spare parts or anything like that. It was just straight from China, and we took a chance. It worked out okay, but the support is kind of what also figures into the price tag for a Mira.
Absolutely. So I've even heard of cases where, I mean, these are pretty specific cases where a customer just can't get it going correctly, and they will have a guy who I think is his full-time job. He literally drives a bus around to your house.
That. Yeah, he'll come to you.
Or fly to you
wow.
and help you get your machine going. So this company definitely cares that you're getting the machine
Yeah.
that you paid for and you're using it. So take that with a grain of salt, as I did get this for free, but I still am trying to give an unbiased opinion
Sure.
on, are they worth it? Because if I was on the other end of the camera, because I kind of was when we took a shot in the dark and bought that OMTech, having zero clue, I'd want the truth pointed out to me. So that's where we're coming from in this video. We're gonna just show the ins and outs of, you know, what the machine looks like, what comes with it, cost, operating costs, stuff like that, and then we'll show a whole bunch of cutting.
Yes, we will.
Let's take a look at the two machines and what features they have and what features they may not have.
Okay, first off, the Aeon Mira 9. We've got overall size of the bed is, I think, 900 by 600 millimeters, which makes, that's about 2 feet by 3 feet, which makes the actual machine take up a significant amount of space. I mean, if there's a downside to having a machine this powerful, that's it. It's the size that it takes up in your shop. On the outside, you can see it's got access panels all the way around on the front, on the sides, panel on the back for the laser tube itself. The Rotary controller is exactly where you'd expect it to be, accessible on the front right. The panic switch is on the side here, but fortunately it's still in red with a yellow housing. That's the activation / ignition, and down here you've got USB cable connection along with the actual USB stick. Opening this sucker up, what we really love is being able to see uninhibited what goes on inside, because basically the entire lid is made out of acrylic that lets you just look straight down into this thing. As I said, 900 by 600 millimeter working bed that comes out to just under 2 feet by 3 feet, like about ½ an inch off of each of those. There are LED strips running down both sides, so not only is it easy to look inside through the window, but it is lit up. You can have a perfect view of what's going on inside. Fit and finish on the inside is just beautiful. I mean, this honeycomb bed is right up against the edge all the way around. There's not any wasted space much at all in there.
There's also no slop in this honeycomb bed.
That's true.
When you slide it in, it stays there. So if you're using any reference points from the edges or anything, that is, you can continuously do it even after you pull out the honeycomb and put it back in.
Yeah. There is a self-calibrating probe on the laser housing itself, which is incredibly useful versus having to measure and calibrate it manually every single time. Also, the bed Z-axis raises and lowers on a motor, so we don't have to twist the knob down here anymore to do it by hand. All right, now to the Orion OMTech 60 watt black and white. On the outside, wow, that's yellow. That's a lot of high contrast. I like it. Okay, starting over here, I like that the panic switch and the ignition are right here on the front. I mean, having it on the side on the Mira 9 is okay, but we used each of these a lot, and it's just more convenient having it right there, right next to the Rotary controller, right where it belongs. The outside of this machine is fine. Like I said, one of the drawbacks is that while it does have a couple of panels that you can see through, they're much smaller than the Mira. This is not a whole window that you can just look right through. It is a heavy metal frame with acrylic glass or acrylic windows in 2 different parts. One thing that we liked more about this Orion is the fact that you don't need a key to get this pass-through slot open. There's just these little releases on the sides. There is another access panel here that you do need the key for. But on the Mira, this thing is only accessible with the key. You can't just come in and click it out, which you're not going to use every time, but when I did something oversized, I like being able to swing that thing open without having to take this thing and fiddle around to get the thing open. All right, looking at the inside, here's the honeycomb, and you can tell, I mean, right away the bed is significantly smaller. I think it's in the neighborhood of 28 by 22 inches is what you've got to work with here. So to compare the cutting size, I'm just gonna grab the honeycomb right out of the Orion and lay it inside the bed of the Mira 9. And there you go. You can see you've got several inches going sideways.
This is a bit deceiving though, but you can see where the black stops on the honeycomb. That's because that's as far as the laser could go back. So even though it exists here, it really stops where this black is. On the Mira, you can see the nozzle goes all the way back to the back metal piece. So you get significantly larger than the Orion, which is deceiving a bit.
Also, another difference we've found is that this thing, putting it back into the Orion, you've got a lot of wiggling going on. Like, it's not set in there in a frame like in the Mira. Again, not really a big issue, but it's just nice to have that fit and finish and know exactly what you're going to have inside.
It's going to be an issue if you are accessing and referencing something off of a corner. That's when you're going to have an issue, because this is going to be exact every time because it only fits in one way with no wiggle room.
Yeah.
This one can go
this
all
may or may
wiggled
not
all
be a
around.
right angle. You could go slightly like that.
Yeah, or forward or backwards.
Or any direction.
So pay attention with that if you are doing this. Some people have screwed this down to the metal, but then if you need to put a rotary or something else in it, you're going to have to take those screws out and remove the honeycomb anyways.
Here's the hand crank for the raising and lowering of the bed. This will get tiresome. As you can see, it is lots of effort for just a little result, and we like the motor much better.
One thing also, that hand crank is right by this linear bearing, which is a sharp piece of metal.
Yes, it is.
And you can see when I grab it, I have cut myself on my finger many, many times.
Bloody knuckles.
Terrible. This one does not have a knob to turn. It's electronic. You'll click in here and it'll go up and down. We'll show that a little bit later.
Looking at the laser, its emitter itself here, you can see it's quite a bit more bulky than the one on the Mira, which I guess might contribute to the fact that it can't go quite as fast as the Mira. You can see the air assist going in here. The lens is embedded inside, but it's just it's significantly larger and slower than the Mira. If you look in the back of the Orion, you can see there is one LED strip in the back, just one, and it's quite a bit shorter than the two that are on the sides of the Mira 9. So it is lit on the inside. You can see all right, but you kind of have to bend over, squint your eyes, and look real carefully.
All right, so I'm going to start this thing up, and depressing is the button is in. It'll probably ship to you that way. You're going to make sure it's popped out, not pressed in to turn it on. All right, once it's depressed, you're going to turn the key, and it's going to kick on. You'll see the lights turned on. The Rotary is powering up, and it will move to the back right. That's where this machine is set up to be home. It'll always home in the back right to start. And it does that a little slowly. It does that with proximity switches. It's not a physical button that pushes. It's this little brown thing. I'll move this out of the way here. You can see this little brown thing right here. That's when metal gets in that proximity, it knows where to stop. So there's not a button, physical button to brake if it so chooses. So you can notice the LEDs are lit up on either side, and they're much closer to the bed, so that lights up the bed pretty well. So that's kind of the turning on of this. Now, if you take a look at the screen, this is your typical Rotary screen. That's typical. If we come over to the OMTech, I'm going to open it up. Okay, so I'm going to come over. There's a button over on the side for the Rotary. Again, our e-stop is not pressed in. And then for the black OMTech, we turn on the control switch like that. You can see our LED is lit up in the back. It's moving to the back left, so it's a different corner than the Aeon does. But our Rotary booted up and is showing the exact same screen. The brains of these machines are exactly the same. Exactly the same. So that is what the two boot up systems look like for both machines. If you take a look right now at either of them, which one is brighter? So that shows you the LED intensity. That back LED almost does nothing. These LEDs on the side light it up tremendously better. So we're going to give a point to the Aeon for LED lighting. Fantastic. All right, let's talk peripherals. So with your laser, you have some other things you're going to need to make it work. And one of those is being some sort of coolant for your laser. You're shooting high plasma at a very hot temperature. We need to keep that cool to prolong the life of the laser tube. So down over here is the best example I can give. This is called a chiller. This brand is an S&A, and it's a CW5200. CW is kind of like the chiller, and the number is kind of how refrigerated it'll go. The 5000 series are actually a refrigerant. A 3000 series is just a recycling of a fan. It doesn't actually refrigerate to get cold. So if you're going to buy one, I recommend the CW 5000 or better. We bought the 5200. It has a few more features. It's all in Celsius, but you want to keep the water cool. So we're at 18 degrees. That's pretty good. You want to be around 18, 19 degrees in your coolant. You could see the size of it. It's sitting right next to the laser. It's not inside this machine. It's an aftermarket we had to buy for the black and yellow. This runs you about $550. So it's $2,500 plus $550. So we're already over $3,000 at this point, just on these two pieces. And you definitely want to invest in this. If you don't invest in a good chiller from the beginning, you're going to be running some like room temperature water out of the tubs they usually give you with this, kind of like a fish pump. You're going to end up changing out your laser tube much more often, which costs a pretty good amount of money. So if you invest in the chiller in the beginning, you're going to actually save money in the long run by prolonging the life of your tube. So we have a chiller, and the next thing we have is an exhaust fan. You can see that the OMTech comes out the side, and it goes into a fan. So right here we have an aftermarket fan. Let me show you the original fan first. And that is this giant, almost airplane-like turbine. It is huge, and it is extremely loud. I don't know if this is going to come through on the screen, but I'm going to plug it in and turn it on, and you'll hear how ridiculously loud this thing is. You can see, and I don't know if this is coming across because I have the mic, I basically cannot talk to Brian in the shop because it is so loud. Now one thing that does, you can see my hand, it's putting out CFM, which will suck and clean out the air. But also, if you have this in your house, in a room, you're not going to be able to function normally. So this needs to be like an outside shop. We got rid of this pretty quickly. These are really cheap that come with the OMTech, and they're not high quality, so they usually die really fast. So we did an inline fan. You can see back here. So I'm just taking this apart right now for you to see, but this is an inline fan from Amazon, and it is much quieter. It doesn't put out as much CFM, but here it is turned on. You can see that I can talk, and it's no big deal. It's not blowing my arm back, but we are moving enough out air-wise to get the smoke and stuff out. So there's a trade-off between the two. Do you want a whole lot of CFM to get the stuff out, but then you can't hear anything? Or do you want less CFM and you can barely tell that the machine is on? So it may be different in your shop, so that extractor that comes with this machine may be right for you. Wasn't for me. If it's not for you as well, check this out. We'll leave links in the description for this inline fan. Lastly, another add-on is the air pump. So when you're pumping, when you're cutting on a machine, you need air to blow the bits that you cut out of that hole, so you're not just recutting the charred material. So we use a little air pump that's usually for like fish tanks or something, to produce air to go out the nozzle. So we use it to produce air to flow out the nozzle where the laser goes, to blow that charred stuff out, and it will cut deeper and faster and cleaner. So this has a rig of some air tubes inside it, and it eventually comes out through here, and it blows out the end of the tube. So that's one thing you'll need. We are using the original one that came with the OMTech, and it's doing a fine job. It's not super powerful. A lot of people have upgraded to like California Air Tools quiet compressors. It doesn't need to be very big, but it does put out way more air than this thing does, and you'll be able to cut a little bit deeper. So that's another thing you need to place somewhere around in your shop. So those are the 3 aftermarket things we have for the OMTech, and they are not built into the machine, but you have to take up space and some place to put these. Also, one other thing that this thing likes to do is when it's on, it tends to want to go like this, and it usually walks somewhere. So you need to, some people suspend it with a bungee cord because it'll put out a lot of vibration. So here's what it sounds like when I turn it on. And you can see it's walking right now, albeit very slowly, and it's doing a little humming. But if it ends up walking and you're not paying attention and it walks into some metal, you'll hear some crazy vibration, and you'll wonder what it is, and you'll forget that this thing has moved on you. So that's the air pump. We did an aftermarket, we just attached a power supply to the side of this, because let's come around back and I'll show you why. You can see that we have the main power for the laser, and they put in a little power supply here with water pump and air pump. You can see it doesn't look like an American plug. However, if you go on to read anything about Chinese lasers, 100%, and this is why we said there was a difference between the Aeon Laser US and the stuff coming off the boat from China, is that the wiring is not up to code, not up to snuff, not big enough to power all this stuff. So we have seen some things burn to the ground because this is improper wiring and improperly grounded. So every suggestion we've ever seen on Facebook groups and forums and suggestions saying, skip this completely and plug directly in the wall. So for us, a more convenient way is to hook up this external power and plug everything over here. So that was another add-on we did. And we have things on individual switches. So if we want to run the air compressor, we can, and we can turn it off when we're not running the air compressor or the fan. We can adjust it from here, and that's how we have it set up. Again, all this stuff takes up space outside of the machine. So let's take a look at how the Mira does with all of these things and where they put it. Okay, you can see back here we have something that looks like what we looked at over on the OMTech. It is the chiller. The chiller is actually built into the machine, which is amazing. We're saving space. We didn't pay extra for it. It was included in the cost, so it wasn't a surprise cost that we needed to buy later. It's built in. Space saving, it's quiet, it's complete, and built directly in the machine. Also, if we pull off this back panel here, we see 2 things. Over on this side, you see this hose, and it's actually pumping right now. This is the air pump. So that little air pump we had sitting outside is actually on and built into the machine, and it's housed to where it's not walking away, it's not vibrating against anything else, and it's very quiet. So that's fantastic. And it's also controlled by software. Positive and negative. Sometimes you're going to forget to turn it on in the software, but it's just another button that we didn't need on the machine because the file will create whether we need this on or off. The third thing that we have is we have the extractor. You can see the hose right here coming to the extractor built in inside the machine. It's a positive as it's in the machine and it's not taking up any space on the ground, but it's also maybe a negative. If it breaks or jacks up, you're going to have a messed up thing inside. I don't foresee that happening. Some people want to change it out to a quieter inline fan like we did with that one. I find this kind of an in-between the giant turbine that comes standard with the China deal and the quiet inline fan in terms of sound. Brian's hitting the button to turn it on, which is on the side. And you can hear that it's over here. It is pretty loud, but it's pretty loud when I have this off. If I put this back on, it does deaden the sound a bit, but you can also see it's much more powerful than the inline fan. We're cranking out a lot more CFM, which is good to get the fumes out. Now we're in my shop and we're doing testing purposes, so we have them side by side right now. We're not venting out to anything. Typically in your house, you want this venting outside, at a window, at a wall, at a door. You don't want to crank the fumes back into your shop. So don't follow us in this video. We're just showing it off, not connected. Okay, one other thing that is kind of a bummer that the Mira has, and maybe a positive, I kind of see it as a negative, is that the stand down below does not come standard. It is an add-on item, and it's pretty expensive. The stand for this is not really so much a stand because it's all built in, so I didn't pay any extra for this. Here's where it's kind of a positive negative thing. Over here you can see if I'm working on the laser, I'm tucked in very low, you know, hunched over. If you can see over at the Mira, it's at more waist height. I'm a short guy, and I can only imagine if you're taller like Brian or anybody else, you're working at a more normal height, which is a positive. If you're going to do this all day long, you're not going to hurt your back bending over. It's kind of dumb, but it is what it is. If you wanted to, you can skip the stand altogether, save that money, and just buy some 2x4s and build yourself a platform. Now, not everybody who's going to buy this machine can just put some 2x4s together, but if you have a little bit of skill and a drill and some nails, you can put a stand together. One benefit to this is that it comes apart very easily, which means if you're going upstairs, downstairs through a narrow doorway, you turn it sideways and it'll fit, and you didn't take everything apart. If you watch the first video where I kind of reviewed this, you'll see how I put this together, and this Mira just sits into some holes. They're not bolted together, but the weight of this is such that it will never come off. You're not going to be able to bump it off the stand. However, with this big OMTech, this is all one piece. Technically, you can separate it from some bolts, maybe around this crease here, and possibly take the feet off. But if you have to go through a large door, or a small door, or up and down stairs, this is going to be incredibly difficult to do. I'm blessed to have double doors in my shop, so I can open them both and just wheel them in. Very easy. If you're coming into a house with a 36-inch front door, this may fit through the front door, but once you start going into a room that's usually a 32-inch, you're not fitting it through the door. So there's a positive, a negative, a blessing, and a curse. You just got to figure out what's for you on this. You may see that the stand as an aftermarket add-on is a benefit because you didn't waste your money on something you weren't going to use, and you're able to get it in your house. So that's the difference between the stands and such. All right, I wanted to show the accessories off and the accoutrement, because it really plays a factor into how big of a space you need for the laser. So let's go over the smaller laser first. What we have originally with the 60 watt anyways is the space we need, let's say 48 inches, 4 foot wide. And that's not including any time you got to stick your hand in and get to any access on the side. Remember, on the side of this we have a computer fan cooling the insides. We have our PC port, so if you're going to plug in a LAN cable, which I suggest you do, you're going to have that poking out the side. So you're going to need to give yourself some extra room. If you just have exactly 4 feet for it to stick in a little space, it's not going to cut it. Ideally, if we're just going off the size of the laser, you'd probably want something more like 52 inches or so to give yourself on the width. All right, on the depth, we're going to check that out. So the depth is 34.5. Now again, that's great when you're going through a 36-inch front door or back door, but if you're going through an internal door that are 32, you're 2 inches too long. So you're not going to be able to fit this through like a bedroom door, unless you have some real fancy bedroom doors. So again, we're going to have cables poking out of that length, because in the back we have a power cable. And we have hoses coming out for the air and the water. We have hoses for the water, and we have hoses for the power. So we're going to have to give ourselves a little extra length.
That's what she said.
All right, so if we give ourselves a little extra length for the cords and such, I would say about 38 inches in depth is what we'd need. So that's kind of the total footprint. Now there's a few other things we need to consider. Where do we put this? We need to put this somewhere. We can tuck that underneath the feet because there's an empty void down there, so not so concerned about that. However, we have our giant piping out the side, and this is the tube that comes with it, which is semi-flexible but not incredibly flexible. You can see we came at a 90-degree angle because I went out the back of my shop to void this out. So at a bare minimum for this hose, I would say 13 inches you're going to have to add. Again, we also have the chiller. The chiller's going to take up some room, and you're going to have to put that somewhere in your house or shop. The chiller is 11.5 inches wide, and in depth we're going to roughly say 24 inches deep. We'll add some for the cables, so we'll say 26 inch deep. So in total in width, that's going to put us farther than we expected. We're going to say about 59 inches for this laser bed. Now with 59 inches in our mind, we're going to come over to the Mira and see how far we can go for this machine. Now we have everything tucked in, so we don't have to worry about external things. And if we measure from one side to the other, we're actually at a smaller width of 51 and a quarter or so. Well, we got the e-stop too. So let's say 52. So it's actually taking up less space in the width for a way bigger bed than this does. Now we do have this back here. And you'll ask, what is this for? This is actually the laser tube. Now if you get a Mira 7 or a Mira 9 that is not 90 watt or 100 watt, you get the 60 watt, this will be absent. So it will cut off right here. I have the 90 watt and the tube doesn't fit within the machine. It has to stick out. It sticks out to about right there. So we have to take that into account for our storage. So if we count this, this is roughly 12 inches. So give yourself a 12-inch gap there. And if we take that all into account, we are at 63 inches in width. So we are a little bit wider in width because of this, but we gained a ton of cutting space with the bigger machine. Also, we have to take in consideration depth. And for depth, we're at about 42 inches. If we give ourselves some room for the air circulating. And this one, what was this one at? This one's about 36 inches. So it's going to take up more room in depth than it is width. So that's the difference in size. Also height, I'll give you a height measurement. From floor with stand to the top, we're at 43.5. From floor to top, we're at 36.5. So we're a bit more compact, but for me, in my house, it's worth the extra few inches for the bigger machine to get a whole lot of inches for more cutting space. That's a huge, huge deal, especially in an environment where you're going to be putting out production. You'll be able to cut more and faster with a bigger work area because you're not spending the time to cut down your material and swap material as often as you would on a smaller work area. So the final thing is the actual laser tube itself. They're both located in the same area. You can see here's the laser tube. Our product information got ripped off because we didn't know what all was connected to this. But it is a tube that is not a brand name, and it was cheap. It's a cheap tube. They stuck in a cheap tube. That's just the answer to that. It works, but it's a cheap tube, and don't expect a really long life or a very powerful two-standard tube on this machine. Not as it comes from the factory. Alright, so the tube on the Mira, you can see, is a Risi. Now from all accounts that I can find, Risi is the brand of brands for tubes. So you're getting the highest quality tube at the best testing. You can see the numbers on here. This is a peak of 102.3 watts. They tested it for a length of time. It's got all the numbers and tests and checks. We know that this is a good tube, and it's worth the money. So this tube is probably 2 to 3 times more expensive than the other tube in the other machine, and that's where you're spending another amount on the more expensive machine. But that's what this tube looks like. We know we have a good brand, and it's going to last a long time if properly taken care of. All right, so let's take a look at the nozzle a little bit closer. I'm going to bring this OMTech forward. Jogging works perfectly fine. But let's take a look at the nozzle. Turn the laser off while I do that. You can see that the nozzle can unscrew right here, and we can adjust it up and down. And our lens is inside, which is pretty fine and normal. So I'll tighten that back up. And we have our air assist coming in the side, which is functioning normal. But you see this little red dot where my finger is. So this is the positioning dot. This tells us exactly where the laser is coming out. And we get that from this right here, which is off to the side. Here's where this design is absolutely terrible. And it's not because I wasn't provided this for free, it's because it's a terrible design. Because you can see how easy it is for me to bump it like so. But you can also watch down here on my finger how big of a difference that is. Now in, contracting, that difference would be perfect. But in laser work, where the laser is as big as a human hair, this is way too far off. And you'll never have this centered longer than maybe an hour. So I never use this red dot on this machine because it is never ever in the actual position where that laser is coming out. That's where I come in with the light burn camera, and that's how I've used this exclusively. Now before I got this machine, I did some research, and a lot of people with the Mira were saying, I got the light burn camera, I never use it, and it bewildered me because this is the only way I can get things so precise. So let's go over to the Mira and I'll show you their red dot. So here's the Mira. We have our laser head here. And you can see if I put my finger underneath that there's a red dot, which is coming out. But all around here, we don't see that laser kind of hanging down to where it's adjustable. And the great thing is that this has a beam combiner inside the machine that is actually shooting the red beam with the actual laser beam in succession to where they come out the nozzle at the same time. There's no way to bang this red dot any out of alignment because it doesn't exist up here, and it will be perfectly aligned to where the laser head is coming out every time, once set. So I've found myself not using the camera as much because that red dot is actually where the laser is going to shoot, and I can reference off that red dot, which is fantastic. So that is the difference between the laser heads. This one is way more precise with the beam combiner, and the OMTech is just absolutely terrible and almost useless. Alright, so this is something you're going to come across and use all the time. Right now, if I want to laser on this, I can't fit it underneath the head. So what I do on this machine is use the Motorized Bed. So I'll hit Z, and with Z move, I can push right, and you'll notice the bed is going down. And if I push left, it goes up. So I'm not twisting any dial or anything, I'm making it go down, and I'm just going to move it right below this little switch here, so it clears underneath the head. Once I've done that, I'm going to come back over here, and I'm going to hit autofocus. And when I hit enter on autofocus, it's going to move the bed up, it's going to bounce off this spring, which is a switch, and it knows exactly how high it needs to be. And now we're perfectly focused between where the laser comes out and its optimal focus point. So that's how easy it is to do it on the Aeon Mira 9. Let's check out the OMTech. Okay, we're at the OMTech. We have the same issue. I need to go down further. So what I have to do here is grab this knob and physically twist the knob to where it'll go underneath here. Now you can see I've messed with that red dot beam and I have no idea where is actually the laser coming out. But what we need to use on the OMTech is a focusing gauge, I had to make this myself. There are plenty of videos out there how to do it. But I've made a focusing gauge, so I have to do this every time. And I've got to go farther down to about right there to focus it. So that is focused. I had to do all of that manually. That really didn't take that much longer, but it was just a lot more effort and manpower to get it to be focused. There's the final two things that are different about the machines. We're going to use the rotary. We're going to do some tumblers. We're going to set it down onto our bed. Again, we have to get down below where we can fit a tumbler on top, and it's all the way down. First things first is we need to push it down. So we're going to go into our Z move, and we're going to go down, and we're just going to hold the button until it goes down far enough for it to fit underneath. Now, that's a significant height because this has got to go below it and the actual tumbler. So we have to go down a pretty far way, and it's going to sit under here and just go back and forth. So we've gone down as far as we can go. That revealed this port over on the side, which is our rotary port. All we do is take our rotary plug and plug it in. Now, if we want to do the same thing over here on our OMTech with our rotary, and these rotaries are aftermarket add-ons for both machines. They don't come with it. I purchased it. I want to get it down below. You can see this one sits way higher. It's way higher up here, so we have to clear this, plus a tumbler. So if I were to just hand crank this, it will take me all day long to crank it, because it has to go really, really far. So what I do with this is I get my Allen key, I take off the knob. Another reason I do this is so I don't slice my finger on the linear rail here. I get a drill like this, I have it open, I put it down onto here, and I close the chuck, and you can see now I'm going to raise it, and I'm going to lower it. You can see my lead screw is bent because it's moving the drill. But could you imagine hand cranking that? I'm not even close yet. I'm still going probably to about there. You can also notice it's got a lot more depth, it seems, from the laser head down to the base, because the rotary is so much bigger. But now I can finally put it in and use it. However, there's no port on the side for me to plug the rotary in. I have to come over to the side of the machine, take off the Y cable, which makes it move back and forth, and unplug it, and then plug it in with the rotary. So the rotary is actually doing the Y's machine movement, and all this will do is go back and forth. Now when I'm finished, I have to unplug it, pull the rotary out, and I'm going to have to wind it all the way back up. And again, if this were the only way I could do it by twisting, that would really suck. I'm using the drill. And then I take it off. And all the while, I've got to be really careful I'm not slicing my finger on that. But that's how I change out from a rotary to the actual laser and drop the Allen key. And if I want to go back over to the Mira and I'm done with the rotary and I pull it out and I'm ready to switch back to flat sheet goods, I'm still in Z move. I just hit the back button. I just unplugged it from here, and it takes 2 seconds. I'm not worried about slicing my fingers open or anything like that, and we are in business. So that's the main differences between the bed and having to adjust it up and down for the rotaries or any fixed stock. This is a much nicer and easier way than this kind of janky way where I'm using a drill to make it go up and down. But if you do have this and you use the drill, there's your tip of the day. Use a drill, it'll make it go faster. So there's one other thing we need to go over, and that's how to get a file from your computer onto either machine. Since they're both the same Ruida controller, which is the brains, they both have the ability to be transferred via USB disk or a LAN cable. You plug in a LAN cable, connect it to your network, and you can send files over the network. That's the way I exclusively do it because it is so much easier and I don't have to get out of my chair. one other option that the Mira has is a Wi-Fi connection. Now, it's not the typical Wi-Fi connection that we're used to. It doesn't connect to your Wi-Fi and then you can access it like a LAN cable. You direct connect via Wi-Fi to the machine. So you'll go down on your computer and select the Mira, and that's a direct connection. You can't get internet that way.
It's got its own signal.
It's got its own signal. It's putting out its own signal. I like to use the LAN cable, but for this purpose, since I'm running 2 machines in the shop and I'm kind of temporarily making this work, we're going to be using the USB sticks.
Yeah.
That way everything's even. We don't have to like
switch back and forth.
Yeah, and one may be getting the signal better than the other.
Yeah.
It's a USB stick. They're loaded the exact same way, and it's a pretty even way to compare the two. So, what do you think about the fit and finish quality? Just over what we've gone over, is this thing worth $8,000 more? What do you think, Brian?
I mean, again, it all depends on what you want and what you're going to use in your shop. There are definite advantages to this machine. I think, especially for me, for the stuff that I've done here, the precision, the speed, and especially the size of the bed on this thing, combined with its ease of use, is a clear winner.
Obviously, if we went with the Mira 7, which is a smaller bed more comparable to that, you're going to be significantly cheaper. I think it's about $1,500.
Okay.
Let me actually look that up. Going from bed size, if we wanted to compare a little bit better, again, this is a much bigger laser, so
yeah.
the price is going to be more expensive because we have a bigger bed. But just in bed size, this one's starting out at about $6,700 for the same bed size, nearly identical to the, what all we invest in that to be comparison? $3,500 or so?
Yeah, about that.
About $3,500. So there's a difference of about $3,000 in the 2 machines if I had the size that is comparable to Mira 7.
Yeah.
All being said, if you had the Mira 7 and it being the same size, is it worth, from what we've gone over so far, to invest in this machine over the OMTech?
I mean, I really couldn't say. For myself, starting out like we did, I think I would still go with the less expensive version, especially if I could have some of the options stuck onto it to customize like we did.
You're talking about the less expensive version of the Mira.
Yes.
You think that's worth it? The Motorized Z, for me, really sets it apart.
Absolutely.
That is amazing. Also, in a small shop like my current one, having everything tucked into the machine and getting a bigger space for about nearly the same size footprint,
right,
that is invaluable.
Absolutely.
Because I can only fit so much in here. I can't go any bigger than what I have.
Nope.
This is as big as I physically can get in this shop.
Yeah.
So that is a huge deal for me. It may not be a huge deal for you. You may have a barn to sit this thing in, so it may not make a difference. I still feel like when you order from this OMTech, especially from Amazon or whatever,
yeah,
it is a shot in the dark if you're getting.
You're taking a chance no matter what.
And I will tell you this: a lot of people have bought this off of my first video a year ago.
Sure.
And there have been plenty of people who have emailed me saying their first shipment of their machine just flat out did not work, and there was no one to contact.
Right.
Some people who bought it through Amazon, like we did, and I suggested, were able to return it and get a replacement.
Yeah.
Some people who bought it straight from the manufacturer were dealing with China, and they did not have such a pleasant return.
That's a bad
experience.
situation to be in.
Exactly. I can tell you for certain, if you get it from the Aeon Laser US, you're not going to have that experience ever.
Right.
And if you do have one that doesn't work, it will be replaced worry-free. I would not worry about something being broken.
So that's definitely something to balance into the cost.
Absolutely.
It's a significant amount more, but the peace of mind and the support that you're going to have for that money is invaluable if you want to make this last long and have it be a good investment in your shop.
Also, support how to use videos. Let's say you're looking at this video and you've never used a laser, and you're looking to me to teach you. You're limited on what you're going to get. You buy that machine and you get nothing with it. There are no videos or training or...
There's nothing out there.
The paperwork that came with it was a joke, too. If you could even read Chinese English.
Nope.
It was pretty terrible. Yeah. So you're going to get this and have to figure it out. And if you're not the kind of guy who can figure it out, guy or gal who can figure it out, you're not going to figure it out. You'll be emailing me, and I'm not tech support for OMTech.
Wait, you're not?
No,
Oh.
I will help you as best I can, but I'm not tech support, it's not the same. That's a huge difference with the Mira and the Aeon Laser, is they have all the support videos, and they do have tech support that will answer your questions, and you're calling a Florida number.
Right, based out of Florida.
People who are natively speaking English to you, telling you how to do this stuff, which, again, this is all peace of mind for you. Is that worth it to you? To some people, they're going to take a gamble like we did.
They will.
We got blessed by the gamble we took.
We got lucky.
Some people are not going to be that fortunate, and they need to get up and running and don't want to hassle, and the Aeon is probably the better way to go for you. I do think that the OMTech is a great entry-level machine.
Sure it is.
It's better than the
K40?
The K40.
It's got a little more power.
Definitely more capable, but you need a space and a doorway to fit it in.
Yeah.
So I'm not knocking the OMTech because it has made us a ton of money.
We love this machine.
It got me into everything we've done.
Yeah.
So fantastic machine for what it is. But once you use a machine like that, you know the idiosyncrasies, you know what it's missing, you know what it's capable of. And once I got the Mira in here and I've started cutting on this, it's kind of like,
there's no turning back.
I got the Ferrari, I'm never going to drive the Toyota Camry anymore. So that's kind of how it feels on this side of the limb. Take that with a grain of salt if you want, because I was provided this for free to show it off like I am in this video. So that's pretty much the main physical characteristics that are different between the two machines. Now we're going to get into some cutting and see how this thing handles cutting, how that thing handles cutting, and what we could really crank out. Again, we fully expect and know that this is going to be able to do deeper, more powerful things.
It's a superior machine.
It's got a bigger, more powerful laser in it.
Yeah.
But let's just see the usage of it. We're not going to go into how to program software in this. That's its
Why
own
not?
video. That's its own video itself. We're going to have pre-programmed stuff, and we're just going to show a whole lot of cutting right here. We're going to try to cut as many different things as we can.
Yeah.
So let's load some files and start cutting some stuff.
All right.
Okay, the first thing we're going to do, we're going to cut some hardboard. So we're going to load this stuff into the machine. So we're doing this via USB. So what I need to do first is calibrate the focus on this. So I'm going to bring it up to where it's over the hardboard. And I'm going to do Z, and I'm going to do autofocus. So we're going to let it focus for the thickness of our material. Try it again and I'll come over. So it just focused, so I'm going to hit back, and then I'm going to go into the controller, go to File, I'm going to do Test Version 1, and I'm going to hit Enter, and I'm going to hit Frame, and it's going to be right within this area. If I hit Frame again, it frames out exactly where it's going to cut. So I'm going to bring the camera in and we'll watch this side cut first. So I'm going to turn on the exhaust fan with the button on the side of the machine. You'll hear it turn on. And then I'm going to hit Start Pause with the Rotary controller. And it's going to cut. Now, I'm going to talk about one feature that this machine has that the other machine does not. Because I just hit start and it wouldn't let me cut, and that's because the door is open. This is a great safety feature if you have kids or anything like that. You want to cut with the door closed, but for filming I need it open. It's because it has a sensor right here that detects metal if it's closed. This one does not. I can open this and cut all day long, and it doesn't care if it's safe. It's just going to let you cut. It doesn't have a sensor. So I'm going to trick that sensor with a piece of metal in front of it to think that it's closed, so you and I can see this a better cut. So let's cut it. And here we go. I turn on the extraction fan. Now these are settings that I don't know if they work or not. I just was trying to cut, so we did not cut through it. in one pass. We cut pretty close. So we're gonna go ahead and try it one more time, see if we cut through. We awesomely have a straight flame shooting off of that. And we cut through our hardboard. A nice clean cut. That was 2 passes. Again, I don't have this dialed in yet because I haven't used it enough. We got a nice clean cut, 2 passes, and it's flawless and it fits back inside the cutout that we've done. We're going to come over to the other machine and do the same thing.
Okay, so to manually focus this laser, you've got to jog it to a point on the bed and then raise or lower the bed. Use the calibration stick that we had and just eyeball this manually to where the lens is at. We know the lens is at that notch on the column in there, so we're about right there. Jog it back out of the way, and then we've got to switch on the air and the extractor. Alright, once I have the file loaded, I've got to make sure that the laser switch on the side is actually thrown, the key is turned, then I can hit start. That was way too fast. So I made a mistake. I didn't set the speed and power accurately in Lightburn. I got a little ahead of myself. So I actually set it way too fast, 400 millimeters a second. I'm going to slow it way down for this 1/8 inch hardboard.
So you can see that this is kind of cut twice as long as the other one. This is just not quite as powerful. You can also maybe not see that if you're cutting with the window open, you're not getting good extraction to suck everything out. Right now, we have a lot of smoke in here.
Through. Oh.
So Brian cut through on this machine in one pass with what settings?
It was 30 millimeters a second at 55 power, I believe.
Perfect. So let's see if we can get a one pass with the other machine.
So that was a successful cut on the OMTech in 1/8 inch hardboard, one pass, 11 millimeters a second at 55% power was a clean cut all the way through.
Okay, this is test cut number 2 of the hardboard. I slowed it down to 20 millimeters a second and 80% power. Let's see if we can get it to cut in one pass. And it did cut through. I just can't get my finger. Where's the knife that you had? It cut through. Just can't poke it out. So we got a clean cut in hardboard. Beautifully clean cut in hardboard at 20 millimeters a second at 80% power. And we're going to compare that to Brian's, who did, what was yours?
This was 11 millimeters a second at 55% power, so lower power but also much lower speed.
I may be able to lower this. I'm not sure that we're going to keep checking on the speeds because we already know that this is twice as fast as this. So we're cutting things out much faster. Hardboard is extremely dense and hard to cut through. So if we can cut through this hardboard, we can cut through a lot of soft materials much easier. So let's move on to another material. Next thing we're going to cut is 1/8 inch birch plywood. This is readily available. It's what we cut 99% of the time on this thing, on the lasers. So we got the same exact piece, it's just cut at an angle. We're going to see how fast we can cut through this material. So we're cutting on this, so let's design a file and do some cuts on this stuff. Okay, we have a different material, so we need to readjust the focus. So I'm going to go into the Z. I'm going to go to autofocus, hit enter, and it's focusing. So we're focused. So I have the test 3 file run. I hit frame. We're going to make sure we're cutting within it. We are. So we're going to run this. All right, here's 20 at 70. I'm going to frame it out. Go over this way a little bit. Turn on the dust fan. And start. Check out if we cut through. Not super clean. The circle's a little hard. Had to poke it out, but we cut through really well. And the quality of this cut is rather insane. I can't fit it in perfectly because it's so good. Something like this. So it really sticks in there. So the kerf of this laser is really small compared to the other one.
All right, recalibration with new material manually on the OMTech. So we're going to jog it into place over the material. Manually calibrate to the level of the lens. Going to drop it down to about there. All right, air and extraction on, laser on. All right, and it falls right out. Looks good. This is 1/4 inch plywood. Again, the setting is 7 millimeters a second at 50% power on the 60 watt OMTech.
Brian will bring in the OMTech, which you could see there's a lot of slop in that. And this one, let's see, I'll try to line up the grain.
Yeah.
That's exactly how the grain goes in. And I have little to no slop going back and forth. I can keep it in there and shake.
Very fine
cut.
cut.
If you shake it, it won't even stay in. So you got way finer of a cut.
Yeah.
And this is about this was at 20, that
Yeah.
was at 7, so
This is
about
7.
3 times.
About 3 times the speed. And
Faster.
this is the advantage of having a faster laser. It may be more powerful, but the less time the laser spends on any one part of this wood, the less it's going to actually gouge out and increase the kerf and burn stuff away. You get a more precise cut.
Absolutely. So that is birch plywood. Let's move on to, this is a 1/4 inch birch plywood.
1/4 inch.
Let's move on to a 1/2 inch.
All right.
See what we can cut.
All right, calibrating to 1/2 inch material. And like Ben tried once, I think I'm going to calibrate down from the surface just a little bit. That means I'm going to calibrate deeper on this meter, not by much. All right, this is going to be 2 millimeters per second at 85% power on this 60-watt Orion. I'm doubting that's going to go all the way through, so I'm going to try to make a second pass. All right. Now again, that was at 2 millimeters a second at basically max power, 85% on this 60 watt. I'm going to try not to disturb it and just pry it up because I really don't think that was enough to get through it. No. No. Looks like looks like we made some decent depth, but still nowhere near going all the way through. I'm going to give it a second pass at the same settings and see what happens.
You can delete the square. I'm just doing circles now and program it for this Lexan. So you can do that now while it's doing whatever it's doing. Speed it up.
I don't think we've ever cut that. I've never cut before that.
Take a guess.
On the, okay.
Well, I programmed it basically at like plexiglass, whatever.
Acrylic?
Yeah, acrylic. It's basically the same thing.
Is it 2 millimeter?
0.93 inches. I don't know what that is in millimeter. Hey, we don't talk like that. But let's not say that at all, okay? Burning my eyes in there.
Yeah.
I'm moving. This thing is rotten. Oh, you're almost done. Just gonna make sure it doesn't catch fire.
That may actually be getting close.
I see.
Nearly set it on fire, though. It's still active charcoal on the edge there.
I bet that lens inside is dirty.
Hmm.
Change
Okay, so there's a lot of smoke in here. We did not actually have the duct hooked outside, just turning it on by force of habit. Nearly set the board on fire. I got close to the edge, and you can see there's still an actual active ember on the edge. There's no chance that this would be any good on a third pass, so I'm just gonna see how far through it got. Well, it got through in some places, but it is not pretty. It is definitely not going to be a circle. Ow! And it's still hot. So that was 2 passes. Oh, there it goes. That was 2 passes, basically as slow as it could go, as powerful as it could go, and if you want to call that a success, then yeah, it can cut through 1/2 inch. But the shape is definitely not preserved, and it is basically a piece of charcoal now, so I'd say unsuccessful.
All right, we're gonna try cutting a 1/2 inch ply on the Mira 9. This is 5 speed, 85 power.
What's it called? Lanex?
Something like that. All right, we just finished. So we'll move this out of the way. And we'll see if we cut through. So we got almost all the way through the circle. If we give it a tap with a hammer. We got the circle in a 1 pass. It's kind of janky, but this plywood is not the best plywood. We're not quite as through with the square. But dialing in the settings, we're going to get that in 1 pass. So 1 pass for that versus 2 pass on the OMTech. We're doing pretty good, at least in speed and power. So that's pretty awesome. All right, we're going to cut about an 1/8 inch acrylic. So I'm just going to set it there. And I'm going to autofocus. Frame it once more. And we're gonna go 50 at 50 and see how it goes. And that's it. Let's see if it cut through. And we got cut through at 50 at 50, and it cut through perfectly. So I probably could have gone even faster, but 50 at 50 is perfect.
Trying 2mm acrylic on the Orion. This is going to be 10 millimeters a second at 40% power. And that is a success. Beautiful dead on. Much slower than the Mira, but still successful.
There's the Mira. They're exactly the same cut, same finish.
Yeah.
Would you cut that at 10?
10.
This was 50, so that's 5 times faster.
Yeah.
The same result. All right, so we're doing some of the exact same stuff, just double as thick. We are at 25 at 80. 25 at 80 gets us through this black 5mm acrylic. All right, we're loaded on the OMTech. We're gonna frame. Good. So we're gonna turn on the air. This is 7mm, or 10 at 70. So about a little more than half the speed. Just finished. And it pops out and gives us the same cut quality as the Mira. So a little less, a little more than half the speed it took to cut through that one. All right, so that's our cut test. Next, we're gonna try just engraving on plywood. We're gonna see how fast we can go in just line mode and then fill mode. See how fast we can go with it still looking good. So this is where theoretically the Mira should shine. So I haven't dialed in any settings, so I'm kind of on the fly going as we are with this video. I've dialed this in really well because I've had this for a year. So this will be dialed in pretty good. This may take a cut or two to get it in, so we'll see how fast they can go comparatively. All right, so what we got here is various different logos of mine and Brian's, and we have them at different speeds and powers. After it cuts, I'll better explain it. We're going from 400mm a second of engraving to 2000, so that's a pretty big difference. We'll see how it comes out. I may be too fast from the start. Let's see. This is real-time engraving. Right now it's going 400mm a second at 30% power. Now we're engraving at 2000 at 50% power, which is rather insane because it is working amazingly. Gosh. All right, we just finished that. Now we're doing 1000 at 50. So we'll see the difference there. All right, we just finished it. You can look back, take a look at what we got here. You can see that's 1,000 at 50. This is fill, that's line. I meant to do line here, but I forgot both of them are fill. You can see that it got a little darker down here. It's just depending on the wood, but that's 2,000 in engraving, which is rather incredible. You can see the size compared to my finger. Then we have 400, which is more kind of realistic. We have a great engrave. It's way, way too powerful for line work. So we could go super fast in line work, but we just need to turn the power down. So, wow, this thing is super fast in engraving. Let's see what this thing can do. Okay, exact same file, same speeds on this machine. Let's see what it can do. Well, I ran it at 400, 1,000, and 2,000. 400, 2,000, and 1,000 speeds.
Oh, sweet.
I'm running the exact same file on this one to see if it'll do it.
Great. Wow. So what was best?
400. But could you do it? Like, if I turned up the power, I could have done.
That's really good.
That's weird. Did it backwards. I don't even know if it could do 2,000. does not look 2000. What does it say over there? In speed.
500 millimeters a second. About 50%.
Interesting. So I have it set for 2000 and we're doing 500 millimeters a second. That means this machine can max out at 500 millimeters a second. So we cannot even come close to 2000. So that's very interesting. We'll see what we do when it tries to go to 1000. If it stays at 500, we're confirmed that we're maxed out at 500 on this machine. Oh, it's got to go to the next set.
Still on the next. Still on the same setting.
Yeah. Oh, it's raining. All right, we're at the next set where I have it at 1000. It looks like it's hitting 500 still, right?
500.
500, so it is maxed out at 500. It cannot go faster than 500, and now we know. All right, we're finished. You can see we got 400 looks good. 500 looks good, which should have been 2,000. 500 looks good, which should have been 1,000. So we're maxed out. Although the engravings look great, don't get me wrong. It just can't compete. Another test we're gonna do just to see if this can get over 2,000 is 2,000 and 3,000, and we're upping the power to see how it looks. So this is just to see really can we go even faster. It's cutting these at 400. This is the same setting I had before, but then when it starts to do the logo, we'll see how it goes. So we're hitting max speed of 1,600. It's not actually 2,000. So it looks like 1,600 is as fast as we can go, and not the 2,000 that I thought we were going earlier, which is still a far cry from 500 for the OMTech. These are default lines, so we can surely get better. I'm just seeing how fast can we go. And we're engraving, or doing lines at 800. So there is a max line and a max engrave. So line is 800, engrave is 1,600. Now we're set to engrave at 3,000, and we're not going to do it, so we're just going to stop right there and cancel it because it's going to do the exact same thing we did over there. Okay, for the final test, the engraving test, we learned that the Aeon Mira 9 can do engraving at not 2,000, it's 1,600 millimeters a second, and the actual line work is 800 millimeters a second. And then the OMTech, the 60 watt, we had 500 is the max it can go in engraving, and 300 for the line work. So absolutely, ooh, 16, it's 500 to 16. It's almost 3 times faster in engraving, like legit 3 times faster engraving on this machine. And we're going from 500 to 800 in line. So, no, 300 to 800.
300 to
800.
Nearly
So,
3 times as fast.
Nearly 3 times as fast in line work. That doesn't matter about the power or anything. That is straight up how fast the machine can go. So is 3 times, I mean, definitively 3 times more production can be done on this machine than that machine. That's really where is this thing worth the extra thousands.
Right.
And if you're doing production, 100%, you're going to make that back within first 1, 2, 3 batches.
Yeah.
And then you're flying through it.
Right.
That thing, worth it.
Worth it.
You're not putting it out as much as this.
I mean, it can get the job done, but it's going to take much longer.
Absolutely.
Much longer.
Yes. But the engraving quality, the line quality, is very similar.
Yeah.
You can see, I can see wavy lines in the OMTech. There's some wavy lines, and I don't really see that at all.
I see it, yeah.
Up on the Mira. So if you're doing line work too, we're hitting max velocity we could possibly go on these things. And I'm not seeing wavy lines on this, but I do see, if you look up close, wavy lines in the OMTech.
Yeah.
So there again, you're going to want to slow it down even more to get straight, clean lines.
That's true.
So you're talking 4 or 5 times faster at that point.
Right.
If we're hitting max. Also, the bigger test was the 1/2 inch we cut through. Now it was a dirty 1/2 inch.
It was a dirty 1/2 inch.
But we got it. This is, again, not dialed in for here. This was quick. Can we make a video of it? But everything else cut really cleanly. Comparison.
Yeah.
Below a 1/2 inch, they can do the same stuff.
More or less, with the same, increase in speed.
Right.
That's the strength of the Mira.
But that, I mean, is at least 3 times slower in everything it does.
Yep.
So definitive proof right there in the numbers and the testing. If you think I didn't test it well, leave a link down below and tell me how I could test it better. And maybe I'll put out a video. But for my home use here, we're 3 times faster in the Mira. And does that justify 3 times more the price?
Depends on what you want to do with it. If you want to crank stuff out and not stop and have, I mean, either the same quality or superior quality as the OMTech, clear winner.
And then you have the customer support with the Aeon is at least 3 times as good as if from nearly 0 to 100%.
Next to none. Like it's
we're doing pretty good there. So if that stuff matters to you, that's the checklist. That's the comparison we've seen here. All right, so the biggest thing for us that makes us love this machine over that machine is 3 times faster. The bed quality, or the bed size, is by far
Size really matters to me and my art projects. I've maxed out this bed on nearly every layered painting that I've done with it, so having that much more really appeals to me. It's going to broaden my horizon.
So Brian's going to make a big project on the Aeon. We've done plenty of projects. You can check that out on our Instagrams. I'm at Myers Woodshop, and Brian is at Fiery Squirrel Art. Check out our Instagrams and Facebooks. You'll see some of that. We've got plenty out on that, but Brian's going to make a big Batman project on this thing, trying to max out the bed, so we're going nearly double the size.
It's going to be close to it.
Close to double the size on that. So we're, he's going to make a YouTube on that. We'll link that in the description below, or a link right up here when it comes out later. And check that out. Your channel is at Fiery Squirrel Art.
Fiery Squirrel Art on YouTube.
He does amazing art. So check that out on YouTube. That's it for this one. I hope it helps decide which laser is right for you. I don't think you can go wrong with either of them. You're going to get the job done. One's just going to get you there a whole lot faster.
Yeah.
I'm going to leave links down in the description below for both of these machines. They are affiliate links, so if you want to help support the channels, please click the links. Where can we find you?
Fiery Squirrel Art, Instagram, YouTube, Facebook.
That's right. And I am Ben with Myers Woodshop. Thanks for watching.
Thanks a lot.
We'll see you on the next one.
Bye.
Happy lasering. But we're going to take an in-depth look at each machine. And cut some things and the outlook. Terrible. And we're going to turn this key. Turn that off.
Was it on?
I didn't. This is an aftermarket job from Amazon. Woo! Let me get that. For me in this tiny shop, less CFM was the winner for me. Maybe different for you. So that, what is that thing called?
What, that? Turbine? I don't know.
Extractor.
Extractor.
Let me start over. Cut that right there and start. Also, if you wanted to, you could skip the stand. Let me rub my nose. Alright, so here's another thing. Which didn't take it really didn't take that much longer. It was just a lot more effort.
A lot more effort.
And also in a small shop like me, again, take this for what it's worth because I was provided this for
free.
For free. Again, take that with a grain of salt because I was provided this for.
How do you fire it? Not you like.
Turn the key.
Okay. So then we're gonna switch it on.
Select the file and hit start.
Oh, is that how that works?
Yeah. That's it for this one, guys. We hope you. Thanks for watching, guys. We appreciate it. Let me start that. That's just freaking terrible. Booyah!
Yeah.